Okay, so we have part 284C3M1b7c8e13c9c6d3p38d19d7b21. And it's line 22f1fa19c3m1b7c8e13c9c6d3p38d19d7b21 X-ray Photoemission Ois Spectra part 6 5G Wow Seti. And there's the alien radio signal. And the data. And this is about the photoemission of electron X-rays and the keyword research WOW data. So this is the line of data that we're looking at, part 5 for the X-ray Photoemission Ois Spectra. The wind's making its howling noises. I started working on this particular point March 15th, and today is May the 12th. So my thoughts. What I did was a Google search on the keywords and found some PDF files, a whole bunch of them. I put them in separate videos, and I plan to do a cross-reference on them when I get to line 27. And it'll be water vapor, and it'll be long-distance communication will be the keywords. So then I took the keyword, and it came from the Ti-sapphire laser plus thin film beam splitters, which went to passive optical network, then radio frequency over glass. Then I added steam and vapor and water vapor plasma treatment of glass surfaces, and now we're back to X-ray Photoemission Ois Spectra. So this is another part of it. Quote from Wiki: theory of core level photoemissions of electrons. In a solid, also inelastic scattering events contribute to the photoemission process, generating electron-hole pairs, which show up as an inelastic tail on the high BE side of the main photoemission peak. So we were talking about electron-hole pairs in an earlier video, probably about 200 videos ago. It is one of the keywords that came up in the data. In some cases, we observe also energy loss features due to plasmon excitations. This can either a final state effect caused by core hole decay, which generates quantized, sorry, I don't know how to say it, electron wave excitations in the solid intrinsic plasmons, or it can be due to excitations induced by photoelectrons traveling from the emitter to the surface, intrinsic plasmons. Due to the reduced coordination number of first layer atoms, the plasma frequency of bulk and surface atoms are related by the following equation. And there's the equation there. So that surface and bulk plasmons can be easily distinguished from each other. Plasmon states in a solid are typically localized at the surface and can strongly affect the electron inelastic mean free path. Vibrational effects. Temperature-dependent atomic lattice vibrations. So this is very interesting because we're talking about temperature. We talk about atomic particles and nuclear reactions. We also talked about lattice and vibrations, and this is about phonons, and I'm talked about creating a photon energy with a variation of things that come up in line 22's data. So this can broaden the core level components, and it's interesting because the core is what we call the middle of the spaceship. I've been calling it the core as well. So core level components and attenuate the interference patterns in the XPD X-ray photoelectron diffraction experiment. Again, we talk about crystals and diffracting signals from them to different nodes and microwires to generate electricity for a UFO spaceship, and also to create a long-distance communications device using several experiments and inventions that have already been created through the files that we found during the doing the research. Again, line 22 is full of all sorts of goodies. So the simplest way to account for vibrational effects is by multiplying the scattered single photoelectron wave function. So it's the 0 with the line through it and a little j beside it, by the Debye-Waller factor. So there's a function there, which I'm not even going to attempt to try to decipher because I have no idea what it means. And it's got the triangle with a k and a 2 to the power of 2, and then a little j underneath the 2. Is the squared magnitude of the wave vector variation caused by scattering, and there's another equation. Is it a temperature-dependent, one-dimensional vibrational mean squared displacement of the j? Again, go to the wiki, you'll be able to look at it there. emitter. In the Debye model, the mean square displacement is calculated in terms of the Debye temperature. So again, we have some sort of equation here. I don't know what that is. That and that. Okay. So again, I'm going to keep looking at X-ray photoemission spectra in the files. And thank you for watching.